is the vitreous humor. In most of your eyes, it's clearly a gelatinous material that sits behind the lens. On the screen, unfortunately, I can't show you the lens in any detail. It would be right here. Okay, it's right here, and then all the vitreous humor behind. This thing here, which is staining kind of tan or brown, this is the cornea. And on your eye, when you hold it up to the light, it should be clear, even though it may be slightly discolored.
What is this hard, like, black ball?
That is the lens.
We don't need to cut to that?
Keep it intact for now. You can play with it later.
All right.
You okay? Did you get a splash?
No.
Okay. All righty. Okay, so let's look at this side here. Once again, folks, optic nerve. Now this tissue here is the retina of the eye. I think you understand that the retina is like a bowl. It makes a 360-degree back of the eyeball. But when you find this tissue, it's the deepest tissue in the eye, you'll see how delicate it is. And you'll see how the vitreous humor in its position keeps the retina adhering to the back of the eyeball, okay, to the choroid layer. Take a look and find the retina and see how delicate. What's that? It's yellow. It's yellow and very delicate.
Oh wow, yeah.
I gotta find out where to cut. I see you.
Third eye.
That is the retina.
Third eye.
Show that.
So you're gonna cut.
Look at that. That is where we find these layers of cells that we learned
Don't
about.
cut my eye.
Really, like,
Okay.
solid, but then it
Okay.
has this jelly.
That's it.
I think that's it.
And when
here.
normally, in this
So
side,
cut
it's
just like.
Oh no, or you pulled it out of here, didn't
So many patients a day. Start looking the same after a while.
It is the deepest layer, but it is in the posterior. It basically, the posterior 2/3
Something
of the
just
eyeball
broke.
have retina. Okay.
It's probably
Oh,
No,
yucky.
I think they messed with the cornea.
Did you get juice?
Okay, how we doing? This is retina here. Yes. Right. Cornea is right up front. Okay, and retina is in its normal position there in front of the cornea. Okay? What? 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 That's a gel. That's the vitreous humor. That fills the posterior portion of the eye.
What's the explanation for this really unusual color?
Good question. Okay, so we'll get there, okay? Hold on. How are we doing on retina? Did we find it? That's the retina. You can see how putting a blob of gel in front of it sort of keeps it plastered to the back.
Yeah.
You've heard of, yeah. So if the retina detaches from that back wall and floats in the eye is no longer able to put the image where it's supposed to be. And so vision gets messed up if the retina moves at all. Nice blob there. Yeah, you can see a little bit of retina there. All right, good. Very delicate. All right. Yeah. I'm coming over there.
Sorry, will you tell us if this is the retina?
Is the retina like a membranous layer that can be pulled back?
That's it. That's it. Yes, it's very light, very delicate.
I didn't expect that.
Okay. Almost done.
And then I guess this is that jelly like fluid control.
Okay.
Am I going in the right direction here? I gotta catch up before you guys.
Okay. Yeah, you've done fine. You can switch to scissors if you like,
Okay.
and then just bring those around.
I didn't expect it to be so spherical.
Sometimes we don't go right through the center, but it's not the end of the world. And the lab manual actually has you do it a little bit differently than this, but
Word for it?
not a very sophisticated cut, but close enough.
Oh, what was that that fell out?
Okay, so let's do this. First thing is, we have what's left of the optic nerve and the sclera. Okay? And then we have the choroid. And the choroid in here is black or shiny green. And then we have the retina right here. Okay? And then we put this back into place. And we have the vitreous humor sort of holding that retina, or at least stabilizing it in the back of the eye. Up front, this cornea here, and then the iris, and the opening known as the pupil.
What's this?
This is the lens.
Oh.
Okay? Okay, let's finish up. We'll finish up. First thing is, get your layers down. Look for the cornea. It is on the opposite side of the eye from the optic nerve. It will be clear. It may be stained a little. It should look a little bit more like a dome than a flat piece, although in a preserved eye, it gets wrinkled quite a bit. Immediately posterior, I can't show it to you up there that well. I can show you the general area, but I can't show it to you very well. This is the cornea right here. Listen up. Cornea right here. Look for the flaps. They're in dissection. The iris looks like flaps. Sheep basically have brown eyes. If you take a forceps, a set of tweezers, and find a flap in here, fold it back and look for the color, the pigmentation, and you know you have the iris. The cornea, look for above and below a flap. Turn it back. If it has sort of a bronze or brown color, it's the iris of the eye. The lens then sits right here, right in this position. Each of you have a lens, I've seen it. Look for the ring of dark lines around the lens. That's where the suspensory ligaments attach the lens to the ciliary muscles. To refresh your memory, the lens is acted upon by muscles of the eye, the intrinsic muscles of the eye. So in a 360-degree circle around the lens, you'll see where the ciliary muscles attach to the eye. Start calling it off if you see them. You see this?
This is so cool.
Okay. No. Okay, I'll show it to you.
Oh my gosh, yeah, this is so cool.
You're saying all the layers? We need pictures of that stuff, because I'm sure the test is going to be with this specimen in addition to the... It's really thin. Wow.
Okay? And it would, no, it would this ridge right back here. Okay? All right? Ring around the lens. Let's take that lens out. Let's just take it out of there. Put it on the tray. Oh, it doesn't want to come out. Okay. Then, see this black ring? That's where it attaches to the ciliary muscles. How about you?
So, yeah, we got it.
Okay, great, good.
The muscle that attaches to is not on our sheet, right?
No. Well, yes, it is, but it's not it's not something we see in the sheep eye very well. The muscle it attached to is called the ciliary body.
Oh, okay, so I thought that's what the black ring around the lens was.
It's where the ligaments attach to it. Okay? How we do over here? Yes? Good. So, ciliary muscles, located about right here. You're going to see
You see it?
a corresponding ridge that is striated like this here.
I'm just saying.
That's where your ciliary muscle is.
The iris.
Those are innervated by the parasympathetic system.
You need a diagram of what it is I'm looking for.
Okay. So, how you guys up here? You find the ring? Find the ring around there?
Yes.
Okay.
The ring is the iris.
All right.
Like this?
It's on around the lens.
Right.
Now, if you have your lens, put it in your fingers and give it a squeeze. Put it in your fingers and give it a squeeze. Squeeze the lens.
Yeah,
It's pretty hard.
pretty hard, yeah.
Okay. Obviously, did he break it? your mouth's open, it's gonna slip in there.
Kind of, yeah.
How does the lens feel? Okay. Obviously, when you preserve something, it's gonna affect it. But this is how your lens feels. And muscles can lead to subtle changes in this lens. And those subtle changes allow you to see things up close versus far away. Okay? Ciliary muscles act on the lens. But I did want you to see what this lens is really like. It's really like a little marble in there.
Yeah.
Now, unfortunately, when you get to be my age, the lens is losing some of its elasticity. And so, the ability to see items up close becomes more of a problem. These glasses have an area that allows me to see up close. Okay? They're multifocal, yeah, but you don't see the little line because I paid extra for it.
Good choice.
All right? Next thing, right behind the lens is the vitreous humor. I think the last thing then is what's up with this shiny area amongst the black layer. The black layer is the choroid of the eye. It is known in humans to be there to absorb light. It is black. What scatters light? Light colors. They bounce off. What absorbs light? Dark colors. They absorb it. But the choroid of this animal also has, in pretty much the area of where their fovea is located, or in the back of the eye, they have a shiny area. What do you think that shiny area is going to do to the light that comes in? It's definitely going to make their eyes glow at night, and it's going to improve vision in the dark. We don't have that. Cats do, okay?
Wait, the shiny area.
Because we are probably, what's that?
You said it would be in like the back, but it's like,
Yeah.
it's a huge
It
area.
is. It is a pretty big area.
So it's that
So,
shiny-
in the sheep,
This one is a lot.
in the sheep, the choroid is black, but it is also shiny. Okay? Shiny green, shiny blue. The last thing I can tell you is, if you found the retina and it's still attached to the eye, follow the retina to where it literally is attached to the eye. And that is where the axons of the ganglion cells become the optic nerve. That is also the blind spot of the eye. So if you get one side or the other of the eye, and the retina is attached there, it makes what looks like a little belly button. And that is where there are no rods and cones. It's known as the optic disc or the blind spot. If you find that, then you've pretty much found everything that I can think of on this eye. What's that? The retina has all of its nerve fibers go to one place. And it looks like a little belly button. And that's right where the optic nerve is located. Okay? And this would be called the optic disc, or the blind spot. You got it, it's right there.
The retina?
You see how the retina does not want to come off of here? That means that retinal fiber in there is becoming part of optic nerve.
Okay, I want to see it.
Yes, take a look. Okay. So take a few minutes and work with this thing. Ask questions, and then I'll provide a bag for you to put your eyes in. And Monday, if you want to review, we'll keep an eye out for you.
So this thin layer that's black in some areas and then shiny like green and blue in other, that layer is called
The choroid.
I gotta open up my book. I don't know what I'm looking at.
Yeah, you can. It doesn't come off as easy as the retina, but yeah, you can do it.
and then
There it
the
goes.
layer actually goes around the entire eye.
Right.
And
It does not come up to the front. It is replaced by the cornea up front. But around the lateral and posterior portions of the eye, that fibrous sclera is the strong part of the eye. It is in white all the way around. It gets very thin up front and then becomes cornea in the very front. The iris, you can see